Hello in class. This tutorial is going to be about regression. So it's an intro to regression. And we create regressions when we want to explore and specify the relationship between two or more variables, okay? You can use it for process optimization as predictors, okay? If we go back and look at our t-tests or our ANOVA, we're trying to see if there's a difference between averages. And here we want to understand the relationship between our independent variables or factors, right? Predictors, and our dependent variable, okay? So in class I asked, can anyone give me a simple regression line? Right? If you recall, that's just slope of a line, y equals mx plus b. All right? Very simple. So when we have a regression line, as shown right here, we want to look at the influence of our variables here, x1 and x2, on y. Okay? And y could be anything that we want. Okay? So instead of going into the math behind regression and the equation right now, I want to use output from minitab to explain that. Okay? So let's look at an example. This is an example from our book. And they're looking at 16 observations here on the operating costs of a finance company. And they want to look at two predictor variables, okay? These predictor variables are called independent variables. And they want to look at overall cost, which is y, okay? So we take those individual values right here, we place them into minitab, we go into regression, and what we're going to do is we're looking at our response variable as cost, right? So that's our dependent variables. Our predictors are new application and number of loans. Those are our independent variables, all right? So we have this output, okay? And there are four things I want to review with you, okay? There's a regression equation, which is right here. So I have our cost is equal to 1566, okay? Plus 8.58 times the number of loans, plus 7.62 times the number of new applications, okay? The second is something called the test on the regression coefficients. We'll go over that in a second. And the correlation, which is the coefficient of determination. How well did we do in creating our regression line, okay? The predictors that we chose, how much error did we were they able to capture in the differences in the response or dependent variable y, which is cost. We have something called the test of significance of regression, okay? This is an analysis of variance, okay? Going back up here, test on regression coefficients, that's just a t-test, okay? So you've seen these before. Okay, so let's go over our equation here, all right? Our dependent or response variable y here is cost. Our intercept or constant b naught is 1,566, okay? So in this case, this is just standard overhead that this finance company or bank has. And let's look at our regression coefficients, okay? B0, B1, and B2 are regression coefficients. X1 and X2 are our independent variables or regressors, all right? So, this 8.58 and the 7.62, what does that mean? Well, for every increase of 1 in the number of loans we have, our overall cost will increase $8.58. Okay? Same thing with new applications. Our costs will increase $7.62 for with every one new application. Okay? So let's go to the next item on the agenda here, our tests on the regression coefficients. All right? So it assessed the value of including each regression coefficient using a t-test. And what we're trying to look at is our null hypothesis for each one of these. So these b, beta, I, they're equal to 0, okay? Well, the reason why we have it as set as 0 is that if that coefficient is 0, that regressor, or independent variable, becomes 0, okay? Our alternate hypothesis that it is not 0, okay? Now remember, our alpha, or significance level we're testing it, is 0.05. So if p is below 0.05, we're going to reject the null hypothesis and keep these factors in, okay? And what we have here is that all of these have have p-values less than our alpha, all right? So we reject the null hypothesis that they're equal, which therefore means that they're not 0, and that means that we can keep them in. And the way that these t-values are calculated here is simple. So we take the coefficient divided by the standard error coefficient, and we're t. So our third item here is called its correlation coefficient of determination. All right, R squared is the amount of variation that the variable we choose to model to describe. So this model describes all but 10% of the variation in y, which is cost. Okay. The R squared adjusted value, here's the difference. It only increases here. What's the difference between R squared and R squared adjusted? Only increases if a significant variable is added to the model. Okay. So you may see a difference here. The one thing about R squared is that as you add a new independent variable or regressor, the R squared may increase, all right? But if you add a regressor or independent variable that is not significant, this R squared will decrease, okay? So our last item here is 4, so test of significance of the regression. So it's how useful is the model, okay? It says whether the entire model is okay. And what it's saying is that our null hypothesis is that are any of the regression coefficients 0? Okay, that's our null hypothesis. If they are such, then we know that our model falls apart. If you're multiplying a 0 times a regressor, you're going to get 0. Okay? So in this case, our p-value is 0. So we know that this is rejected. Okay? And then we know that there are at least one of our regression coefficients that aren't 0, okay? And then you go individually back to step 2, right? And we use a t-test there for the individual regression coefficients. This is for the model itself, and then the t-value is for each individual coefficient. And that is how you use minitab for a simple regression. Thanks.